not gonna do it. Okay, well, the force diagram was pretty easy. Remember part B, and I'll show well, you have the answers, so I don't have to show it. But for part B, it was just do the sum of the forces in the y direction. For part C, it was just do the sum of the forces in the x direction. On the axes below, we did that ad nauseum at the beginning when I was trying to connect, what calculus is and slopes and all that junk. We did x looking like a parabola, v looking like a straight, a line, and then a being a constant. Remember when we did that? It's like this. Okay, so we did that a lot. So hopefully that part, B, C, and D, no worries. For E, that was, I don't know, frankly, the only interesting part of this problem. And now we're approaching that. So I've done this force diagram here. And do you see that as F1 gets bigger, Fn gets smaller?
How does it get smaller? It has to equal.
Right? Because if there's no F1, what is Fn? It's just Fg or Mg, however you answered that. Okay? As I apply F1, do you see that I'm causing the contact force between the block and the surface to get less and less? It's like if I pull up on your desk, as I pull up on your desk, the force between your desk and the ground goes down. If your desk was sitting on a scale, right, and I grabbed it and lifted, you would see the numbers on the scale go down. And that indicates that the normal force is decreasing. Because in this, remember, Fn plus F1, I don't know why, because I'm running out of room. That's true, right? And if this gets bigger, then this gets smaller, because Fn is a reaction force. And what happens when this becomes 0? Yeah, if I exert any more force, it lifts off the ground, just like that. Okay? So, all that background was to answer this question. Let's see, what did it say? Derive an expression for the magnitude of the greatest acceleration that the block can have. Okay, so I know the sum of the forces in the x is ma, and that's F1 cos theta minus F sub f, I think that's all there was, equals ma, and then sum of the forces in the y is equal to 0, because if it's still maintaining contact, that means we're still at 0. We don't have a net force yet. And in that case, we know that it's F1 sine theta plus Fn is equal to Fg. Okay, and then so in this case, let me see.
So basically you just set it to equal F.
Oh, that's interesting, because if there's no normal force, so at max F1, Fn is 0. We just determined that, right? If that's 0, then that's 0. Because F sub f is mu F sub n, right? If there's no contact force, there's no friction. So then, the greatest acceleration.
But it still has to still maintain contact with the ground.
Yeah, it's just there's no force. So, wow, that's interesting. F1 cosine theta is equal to ma. So is A F1 cosine theta over m.
That's the answer?
Intriguing. Well, they said for A, right? Well, let's go take a look. Ding.
Can you explain why
Okay. It's just because you're touching something doesn't mean there has to be a force in between you. Right? If you're in zero gravity and you're touching an object, If nobody's moving, you could just be sitting there. And as long as you're not applying any force into the object, there's no F sub n. Yeah. So, and that's their logic, which we did also. See, it did some of the forces in the X. Whoa. Some of the forces in the Y. In both cases, they said n is 0, therefore force of friction is 0, right? And then just got those two statements. Any questions on that?
If n is 0, then isn't it floating?
Sort of, yes.
But the question says that it's in context.
Yeah. Well, it's floating in that it's floating exactly on the surface.
Is it still defined as in context?
Yeah, it can be in contact. There's no reason. Oops.